So hydration, I think we have discussed this. Formation of compound hydration products. After reaching saturation concentration, compound of hydrate product precipitate out as a solids. In latter stage, the products form a very near surface to the anhydrous cement paste and prevailing further dissolution. Now, this is very important because what happens is some of the particles they may not reach your water. So even after 10 years, 20 years, if you see the concrete, few particles are not hydrated at all. So 100% hydration is not possible with this cement because when you are mixing in mixing process we'll come to that. In mixing, some of the particles are remain dry and where their water may not reach. So when water is not reaching, particle remain unhydrated. So 100% hydration may not possible for the process. So that if you go in details and see under microscope, you will understand because we have studied in ACC the concrete strength development up to 10 years. And after 10 years, it was found that some of the cement has not yet hydrated 100%. Mainly they reach at the level of 90 to 95%. So 5% unhydrated particles are available after 10 years even. Concrete has. So gaining of concrete strength as per our requirement, if you are heard in the literature or as per the site requirements, we are stopping at 28 days. See, once the 28 days strength is over, we are happy. But hydration doesn't stop at that level. Hydration is a continuous process. As I said, it may go 10 years, 20 years, 30 years, go on gaining the strength. So if you keep the cubes for 28 days and then you use for 90 days and 180 days and after 1 year, you will find there is a gain in the strength. But gaining percentage may not be that what we are gaining from 7 to 28 days. But definitely there is no retrogression, means it's not falling the strength, it is go on increasing the strength as the hydration takes place. So one has to understand this, and we are working on the project. We will not restrict ourselves only for 28 days. We have to look beyond 28 days also, especially when you are working for foundations. Foundation of the building, everybody is insisting for 28 days strength. But if you look at the design and the construction time, the total load on the foundation it comes maybe after 2 years or 3 years. Still, we are insisting that strength should come at 28 days. You must think on those points why really it is required. Or I can design a concrete which will have 90 days or 180 days or 1 year strength. Then you optimize your mix proportions. In the whole process of your making concrete, cement is the costliest ingredient in the whole process. So one has to see how I can optimize the consumption of cement. That is your skill without affecting the project requirements. So as I discussed earlier, the formation of hydration process over time leads to evaluation of heat, then stiffening. Stiffening means loss of workability. Suppose it is stiffened, maybe somewhere after half an hour or after 1 hour, it's very difficult to work again. Once is lost his workability. And then once his lost his workability, starts working on for setting. Now setting and stiffening is totally different. Stiff concrete can be vibrated, but set concrete cannot be vibrated. So once the setting has taken place, concrete start gaining the strength. That's called hardening. So stiffening, setting and hardening. One must understand this very carefully and implement at site. Now, lot of admixtures are available. So this loss of workability I can control. Maybe 2 hours, 3 hours, 10 hours, even at 24 hours or 48 hours. So I can keep my concrete alive even after 72 hours using certain chemicals. That is possible today. Or I can reduce the work sitting time, maybe 1 hour or 2 hours. So within 2 hours, I can get some certain strength for the certain applications. That is also possible. So this is how water and then cement particles, and these are the crystals growth. And then if you see under microscope, you get picture like this. These are all needles of LO3, CaO and other things. And this create a bond between your aggregate and paste. So if you see concrete under microscope is totally different. And from that you can find out. Now normal concrete may not possible, but when you go for the high performance concrete, it is very necessary to understand how they are reacting with the cement paste and aggregate bond, their transition zone, how they transferring the stress between aggregate to paste. That needs to understand very carefully when you are working for a high performance concrete or having a more durable concrete. So our aim to make a concrete is to make paste very, very dense, possible dense. So this is again a hydration process. I'll not spend much time because it is not very useful, but you can have books are available in this. You can read this. See, C3 hydration is more rapid. You can understand this. I'll show you for in here also. 2 to 3 hours to 14 days. And C2S hydration slowly contributes later strength. So earlier strength you get with C3S, and it is also evolve more heat. From that you can understand which component I had to control to the heats. And if I want later strength, I can have a C2S. Now this, you can see the morphology of this, how the shape of the crystals available, space available, occupy 22 mm solid volume in hydrated cement paste. It does not contribute strength, keeps pore solution in alkaline. Now alkalinity of the cement paste or concrete has to maintain within this, which is also protecting your steel. So with the time when it is carbonated, it is reduced to 9, 10 like that. Then it is start reducing its durability. So cement is always a alkaline material. That's why if you add acid, you'll see dissolving that. So in the cement paste, also there is a voids, because if you see the cement hydration, we need only 25%, 20 to 25% water. In water cement ratio 0.2 to 0.25 is sufficient for hydration of the paste. But normally we work water cement ratio more than 0.25. Now certain level we are working 0.2 also, 0.15 also. But general concrete, may you make M30, M40, we work at 0.4 or 0.45 water cement ratio. Now for hydration you need 0.25 and you are working at 0.5 water cement ratio, you are able to achieve the strengths. Then the additional water, what happens? It evaporates and having voids in the paste. Now this voids reduce the strength, stress distribution and permeability also it is reduced. Now freezing thaw resistance also affecting on the voids in the present in the cement paste. That one has to understand. So when you are saying adding water, water always you have to add for the optimum use. As per application, if you I need about 100 slum, then I can design only 100 plus minus 20 I cannot design, I should not design a concrete for 180 or 200 slum. That extra water is required also extra cement. As I said, cement is a costly thing, and more cement will have more problem. That also will come in subsequent lectures. Why more cement is having an issue in the concrete. You may get certain level of strength, but again, an optimized strength will come. But once you add more cement, you will have more problems. So one basic thumb rule as a civil engineer to remember is more cement having more issue, more water having more issues. So optimum water and optimum cement you must to achieve a optimum quality of your concrete. Now, if you see the physical properties of the cement, which are mandatory as per IS code. In subsequent slide, we'll see what are the IS code is also. So physical properties of the cement, and which is also required for your designing the concrete. Specific gravity of the material, mean that cement. What is the fineness? Now fineness is also in the how fine is, how is the coarser it. Coarser material take more time to react. Fine material will get less time for reaction. Then consistency. Consistency is nothing but the particular cement having particular fineness and particular composition required certain amount of water to make a paste as a standard paste. That IS has specified that IS 401331 has specified that is so much water to be used in making cement strength mortar. When you are testing cement in mortar, it is a standard is available. So we have to use that standard and then we'll have to use. Then we have to find out the setting time. Now setting time of this setting time is a setting time of cement paste in standard environmental conditions. Standard in the sense temperature they are given 27 plus minus 2. Relative humidity 65% around. On that condition, if you do the testing with formula of consistency, you can find out initial setting time and also final setting time. And that also they're specified. I'll show you that what is the requirement as per Indian standard. But don't try to you do cement testing at site unless you have proper arrangement for testing cement. In the sense, all the environmental condition needs to be met with. Otherwise, totally different picture will come. Even compressive strength, they say that particular source of sand has to be used. Now, currently we are getting only from Minor, it is from Chennai, that quartz sand having minimum water absorption levels. So that only we have to use. The specimen size is also totally different. The specimen size is around 70 70.7 You have to use cube size and the mortar, standard vibration. So there's all procedures given in IS code. So those who are interested to understand the cement testing properly, physical test, you must go through that. And with a big project, it's possible to create a facility because you are receiving huge amount of cement. You need to know what is the quality of cement coming, and we are coming with different source of cement also. Maybe same manufacturer but different factories. Then also it is affecting. Maybe because requirement in IS code is totally different. But what your interest is as a civil engineer, I have to use this cement in concrete. So I had to check performance in concrete. Though physical properties are meeting as per the requirement, but sometimes you will find you are not able to get desired properties in the concrete. Then you have to go for the in detail working. Then soundness, how it is sound means is a, either is a expansion is there or there is a contraction is there, that can you find out, because cement also should be stable in nature after hydration. But naturally there is a shrinkage is there. There is a part of your property of a cement, but that has to manage in designs. So this is the type of cements available. There is a few code which is generally we use in our civil engineering, because a lot of other type of cements also available. I am not refractory cement, all these things I am not added in this. But now our earlier for 43 grade, 53 grade cement, here 33 grade, 43 and 53, three grades. There's a three different IS code was there. This 269, then 8229, and then 12269. This is the earlier numbers. Now in 2005, they are all the Portland cement aligned and come in the one single code. That is IS 269. So that is the latest one. And all civil engineer, you must have copy of these codes. Whatever I am discussing, you must note down the IS codes and see that at least you should go through these codes, because codes are designed to have a, for the civil engineering purpose. So a lot of interpretation, their results are available. So when you are stuck up somewhere, you must use the codes and go through these codes to have a better understanding about quality of cement. So OPC 269 2015, this is the minimum requirement strength as Newton per mm square, 3 days, 7 days and 28 days when you tested in the standard sand with the standard condition. Now earlier what is happening in cement factory, same cement they are packing into the two different grades like 33 or 43 or 43 or 53. Because looking at cement is very difficult to understand whether it is 43 grade cement or it is 53 grade cement. So then what IS has done is they have given a upper limit also for these two grades. Once 30, your 33 grade cement is there, the upper limit is 48. Now we have 48 also means it is also meeting requirement of 43. So 43 grade also there is upper limit of 58. So 58 means your 53 requirement is here. You can see here. So if you come 55, you can call as a 43 grade also. It is 53 grade also. So earlier what is happening is 53 grade cement generally give around 60 plus strength at 28 days. This is a minimum requirement. But with the competition in the market, people, cement manufacturer always keep 60 plus. So once it is come 60 plus, then only it is called as a 43 grade. Otherwise, it may be around 43 grade cement. Now this strength also influence on the concrete strength. So this one has to remember very carefully about these requirements. Secondly, this S is basically a sleeper grade cement. These all railway sleepers, they need early strength. That's why they got a different grade, sleeper grade cement. They are included. Here see it is 37.5. Even though 43 here 33, here 37.5. And even also 53 years also 37.5. So this is a sleeper grade cement available in the market. So one has to see this, and accordingly you can design your concrete. Then you have PSC, Portland Slag Cement, IS 455. They're all strength level of about 33. Then IS 1489, Portland Pozzolana Cement. You can have fly ash based cement, or you have burnt clay bricks, means calcine based cement. Here slag from steel industry. Here you can get fly ash from your thermal power stations and have a cement. So 1489 is a Portland slag cement. If you see loose cement, whatever available in the market, in the bags, roughly it is a PSC or PPC. Very rarely you get 53 grade cement in the market. Then SRC, sulfate resisting cement, where the sulfate is the issue. Because sulfate is also reacting with aluminates and can form a calcium sulfoaluminates, and calcium sulfoaluminate has the capacity to expand, and it will disturb the texture of total core of the concrete. So we can use in that location, use only sulfate resistant cement. But this is where the sulfates are more in the soil or in the water. But where the soil having sulfate and as well as chlorides, then better not to use this. We have other combination, we can go ahead with this. Better not to go only for the chloride. Like in Mumbai, we are very near to the sea, and sea has got both sulfates as the chlorides. So here SRC is not desirable to use. If only sulfate is there, then only. Then you have white cement, IS 8042. See the requirement. Around 90% of or 80% of this 33 grade. Then new cement has introduced now in the market 16415 in IS 2015, because these are all revisions, but this is introduced new cement. This is basically a combination of OPC, fly ash, and GGBS. This is a triple bend cement. That's why it is called composite cement. So we, as we know that triple bend cement very good for durability of concrete structures. And now this triple bend for small sites where the batching facilities are not possible, then it is very difficult to make the concrete at site. But still I want a durable structure. Suppose I have to build my own bungalow where I have to make concrete, maybe M30 or M20, 25, M30, and I have to use all OPC, PPC, OPC, fly ash, and slag. Have a very durable concrete. Then it is very difficult for batching, because we don't have that much batching. We do by volume batching. Maximum we can have wave batching. But making concrete at and blending is very difficult. So they have come out with the one cement which can be used as a composite cement, have a better properties. Those strengths are not that very high, but it has got very good durable structures we can make using composite cement. You can go through these specs for the more details.